diagnosis of an ECU and peripherals. The complexity of implementing all of this control, all of these inputs and all of these outputs requires relatively advanced self-diagnostic capability. Traditional engine diagnosis becomes obsolete. The inputs and outputs of an ECU are individually monitored by the processor, often dozens of times a second, to ensure that they are within the tolerances set in the software. If a sensor reading falls outside of these tolerances for the predetermined period of time, a fault is registered and a fault code stored for a retrieval by the technician. Fault codes. When a fault code is stored in the memory, it usually results in some of the logic within the software being bypassed with a reduced engine efficiency, albeit with the engine still being able to function on a basic level. In some circumstances, the self-diagnosis routine discovers a serious fault that either fundamentally prevents the engine from running or shuts the engine down in the interest of safety. With modern engine management, the first fault diagnosis step for a vehicle technician is to access fault codes from the ECU memory. These are often stored as 5-digit alphanumeric codes beginning with P, B, C, or U, followed by 4 numbers. Details of these codes and their description you can see in this figure. In addition to these codes, the technician can also view live sensor data through the diagnosis tool while the vehicle is running. This allows them to see a sensor reading that is incorrect but not out of tolerance by enough of margin to flag a fault code. Electronic throttle control. Many people question the necessity of drive-by-wire throttle control, introduced in the 90s. It's now fitted to almost every engine produced today. But what are the advantages over a traditional cable? Until 80s, most throttle accelerator control was managed with a cable from the pedal to carburetor. The idle speed was set by simply adjusting a screw to keep the throttle flap open slightly until the engine idled correctly. This simple method required regular adjustment of the idle speed and was prone to deviation when an engine was cold or as various parts wore out. In the 1980s, with the mainstream introduction of ECUs, electronic idle air control valves were introduced which solved many of these issues. However, the ECU was not controlling part of the airflow and yet all of the other components remained. With efficiency of an engine operation and efficiency in a car assembly moving forward, electronic throttle control was introduced. This sped up the manufacture of a car, no throttle cables passing through the firewall. It removed the need for an idle air control valve, and it allowed the engine ECU additional control over the engine for improved EGR function, improved control over engine shutdown, and improved starting. One important advantage of electronic throttle control is that the ECU can adjust the throttle angle during acceleration to complement the actual airflow through the engine. This improves the speed at which the air passes through the intake and provides gains in torque and drivability. This is known as torque mapping and is only possible with electronic throttle control. Adaptations. Modern vehicles are built to much tighter tolerances than those of the past. However, they are still susceptible to manufacturing variations, mechanical wear, and environmental aspects. As such, they are able to adapt to gradual changes in the operation of the engine. For example, as an air filter gets blocked by the dust, the ECU can start the engine running with a slightly reduced fuel injection quantity to compensate. This allows it to perform at peak efficiency from engine startup, rather than starting at factory levels and working towards the optimum mixture on each journey. It does this by storing the lambda values over previous journeys. These adaptations apply not just to blocked air filters, but to many systems on an engine or transmission. As components in hydraulic system wear, they require changes to the timing of solenoid activation to compensate. Similarly, as the engine wears throughout, the ability to be an air pump deteriorates slightly, and the opening angle of the throttle flap will need to be changed to maintain correct idle speed.